Good evening, my YouTube viewers. It's Crystal here. I'm just here because I wanted to give you another code review. And this code review is going to be on Tensorflow because I've decided that I want to improve my skills. So I've decided that I'm going to learn Tensorflow. So the code reviews that I'm going to be giving in the future, or if I can do it, if I'm able to do it, are going to be on Tensorflow. I also found out today, just doing some research on Google, that Tensorflow is actually more popular than sklearn, which I didn't know that. So this is an old data set that I probably have given a code review on before, but it's going to be on Tensorflow. So first thing we'll do is we'll talk about the fact that I ran the computer program, and what I will do is I will zoom it to make it a little bit easier for you to see, because I did actually get a message from somebody asking me to zoom it, so it's easier for you to see on your screen. I've made the I've made the text larger, so I hope you can see it on your screen. So the problem statement for the Titanic dataset is: the sinking of the Titanic is one of the most infamous shipwrecks in history. On April 15, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with an iceberg. Unfortunately, there weren't enough lifeboats for everyone on board, resulting in the death of 1,502 out of 2,224 passengers and crew. While there was some element of luck involved in surviving, it seems some group of people were more likely to survive than others. In this challenge, we ask you to build a predictive model that answers the question, what sorts of people were more likely to survive, using passenger data, i.e. name, age, gender, socioeconomic class, etc. Excuse me. I'm getting over a cold, and it takes me a really long time to get over a cold because I have COPD. And basically, I can tell you the types of people that were more likely to survive. It was more likely women and children and people in the upper classes who were more likely to survive. Okay, so the first thing we're going to talk about is the fact that we have written this program in Google Colab, which is a free online Jupyter notebook hosted by Google. And it's a great online platform, except for the fact that it doesn't have a very good undo function. So if you accidentally delete or overwrite any data, you can go into the saved history, and you might be able to retrieve old data in the saved history. So I have accidentally overwritten and deleted data in before, and that's how I went ahead and retrieved the data. But there have been a few occasions when I couldn't retrieve the data, so you do have to be really careful. So the first thing we're going to do is we're going to load libraries, and so we're going to load import pandas as PD, that's your data processing library. Import NumPy as NP, that's your numerical computation library. Import matplotlib.pyplot as PLT, that's your graphic visualization library. And import Seaborn as SNS, and that's your another graphic library. We're also going to import sklearn, which is your machine learning library, and we're going to import Tensorflow and Keras Tensorflow, and those are your neural networks. But we will be importing those later on in the program, because I don't generally like to import all of the programs at once. I mean, some people will import all of the programs at once, but I don't like to do that. And then after we have loaded the libraries or imported the libraries, then what we need to do is we need to load and read the file. So I just called the Titanic dataset off a GitHub account, and that's what I got. That's what I've got. And then so we've got the data here. So you can see the data here. And it's 1309 rows by 7 columns. Gives you an ID, a P class, survived, sex, age, B, and fair. Then we describe it. That gives you your statistics. So the describe is going to just take care of the numeric columns. So it tells you who has survived and the passenger class that they're in. We look at the information on the data set. So you can see there are 3 integer columns and 4 object columns. And the thing that you need to keep in mind is the fact that the computer wants the features to be numeric. So during the program, we're going to have to convert the object columns to numeric columns. So what we're going to do is, because this age in the fair has commas instead of full stops. So what we have to do is we have to replace the comma with a full stop. Okay, and then what we're going to do is now we're going to convert some object columns to floats. So we're going to convert the age and the fair to floats. And then we're going to check for null values. The age, we have 263 null values, and the fair, we have 1 null value. So what we're going to do is we're going to replace the null values in the data set with 0. So anything with a null value is now going to be 0. Check for null values again. So we data fill NA. We check for null values again, and it still was age and fair. So I think that should have been in place equals 1. And then, but it did actually work in the end, but I think we probably should have done in place equals, in place equals true. And then data, we check the data again. So we've got 1, 2, 3, 4, 5 numeric columns and 2 object columns. And what we're going to do is we're going to impute the age. So if it's an adult and the age is a null column, then we're going to give it an age of 28 and the median age of the column, which I believe was 28. And then if it's a child and it's a null, then it's going to have a median age of 9, because I just figured, well, that's how old a child would be. And then we check for null columns, null values again. So the age, no more null values, that's been corrected, but we still have 1 null value in the fair. So the fair is going to be given the median value, which we could easily have put mean in there, but I just put median in there for some reason. Now we're going to do a performance analysis, but I'm just going to skim right through that. And the reason why I'm going to skim right through that is because what I want to talk about is Tensorflow. So we analyze the survived. So you can see you have more people who perished than survived. So you can see that. And you had we had 61.8% perished and 38.19% survived. The sex, you had fewer females than males. You had 35.59% females and 64.4% males. The passenger class, you had more people in third class and the least amount of people in second class. And then you had a little bit more people in first class. And it was females and children and people in the first and second classes who were more likely to survive. We checked adults and children. So we had adults, you had 91.67% adults and 8.32% children. We checked your age. We did a violin chart of the age, and the median age was about 28. But we had some newborns and some really old people as well. We checked the fare. And so we did a violin chart of the fare. So we had some fares as much as 500 pounds, and we had some fares that weren't that expensive either. And then I did a scatter plot of the people who survived. And I believe it was, if it was a 1, it was green. And if it was a 0, it was red. So all of the greens were survivors and all of the reds were not survivors. But I really do like this scatter plot. I think it looks great. So we're just going to filter out the survivors, made a data frame of the people that survived. And so of the people that survived, it was more females than males survived. Survived passenger class. Of the people that survived, it was more people in the first class that survived, and some people in the third class, and then some people in the second class. Whether they were adult and children, these were survivors. So you had more adults than children survived. And then we did a violin chart of the age. So it was about 28 years old. So again, you had some really old people and some newborns. So we checked the fare. So you had some fares that were really high and some fares that were not so high. And then so now what we're going to do is we're going to ordinal encode the categorical columns. And how we did that was we replaced male with a 1 and female with a 2. And we were going to replace all the 1 with 2. And we were going to convert age and fare to an integer. So you can see that now we have the data frame and it's all numbers. It's all numbers, which is what the computer wants to see. So we're going to define our infinite independent variables